Hello, Year 10. I hope you're all doing well. So I created this video because I received a message from our internet service provider that there's going to be a service interruption today. So, as to not disrupt our class, please tune in this video. So to start with our discussion, let's begin with the checking of assignments. So I hope you were able to upload in our Google Classroom your assignments. And you were asked to answer exercise 3.2, page 63, numbers 1B, 1C, 1E, 2B, and 2C. So let's begin discussing the assignment. And please check your paper and make some notes on the things that you were not able to answer. Okay. So let's begin with 1B. So you are asked to solve graphically the modulus of 2x plus c less than 5. Okay. So solving this graphically, let's start with graphing y is equal to 5. So if this is our graph, so let this be our x-axis, okay, and this be our y-axis. So y is equal to 5 would be 1, 2, 3, 4, 5. So that would be here. Okay. So let this line be equal to y is equal to 5. Okay. Then after that, we also graph y is equal to the modulus of 2x plus 6. Okay. So in graphing this, we need our table of values, right? So let's begin with the y-intercept wherein x is 0. So if x is 0, y is equal to 6. Okay. Then we also get the x-intercept. To get the x-intercept, we need to plug in 0 to y. So that is y is equal to 0. So if y is equal to 0, then x is negative 3. Okay. Then note that we have here y is equal to 5. So we would like to get the intersection of this graph with y is equal to 5. So if we would get that intersection, we need to let y be equal to 5 and then solve for x. But doing so, if y is equal to 5, then that would be 5 is equal to 2x plus 6. But since this is a modulus, then there are two possibilities. That is 5 can also be the negative of 2x plus 6. Okay, then let's solve for x. So this is 5 minus 6 is equal to 2x, or that is negative 1 is equal to 2x, or that is negative 1/2 is equal to x. Okay, then let's do this side. So we have 5 is equal to negative 2x minus 6, or that is equal to 2x is equal to negative 6 minus 5, or 2x is equal to negative 11, or x is equal to negative 11 over 2. So we have two possibilities here. So we have 5. If y is 5, then x is negative 1/2. And if y is 5, then x is negative 11 over 2. So we can now graph. So let me use another color. So we have 0, 6. So 0, 6 is on the y-axis. So 1, 2, 3, 4, 5, 6. Then we have negative 3, 0. So this is on the x-axis. So this is negative 1, negative 2, negative 3, 0. Okay. Then we have negative 1/2, 5. So it's probably here. And then negative 1/2 would be somewhere here in the middle. Then 5. Okay. Then we have negative 11 over 2, 5. Negative 11 over 2 is negative 5.5. So we have 1, 2, 3, 4, 5.5. So then we have 5. So we can now graph. So we know that the graph would be a V shape, right? Okay. So therefore, this is the graph of y is equal to the modulus of 2x plus 6. Okay. So what would be the solution set? The solution set would be all the values that are less than 5. So we will be looking for the values of x that falls under or falls below the y equals 5. So we are interested with this part of the graph, since this part of the graph falls below the y equals 5 line. So this shall be our solution set. And what are the values of x? Okay, so the value of x here is, this is negative 11 over 2. And the value of x here is negative 1/2. So therefore, our solution set is x from here up to here. So x is greater than negative 11 over 2, but less than negative 1/2. Okay, so if you were able to graph it this way, give yourself 1 point. And if you're able to identify the solution set correctly, give yourself another point. Okay, and let's go to 1C. So let's now proceed to the next one. So 1C, we are asked to solve graphically the modulus of 3x plus 1 minus 3 less than or equal to 1. So what we're going to do is we are going to isolate the modulus at one side. So this is the modulus of 3x plus 1 is less than or equal to 1 plus 3. And that will be the modulus of 3x plus 1 is less than or equal to 4. Okay, so now that we have isolated the modulus at one side, we can now graph. So again, the first one that we're going to graph is y is equal to 4. So if this is our graph, okay, so this is our x-axis. Let this be our x-axis. Then let this be our y-axis. Okay, so we're going to graph y is equal to 4. So that would be 1, 2, 3, 4. So this is where y equals 4 is. Okay. Then we now graph the modulus. That is 3x plus 1. So again, to do this, we need to have the table of values, right? So we have x and y. So we need to get first the y-intercept. So to get y-intercept, we need to plug in 0 to x. So solve for y. If x is 0, then y is equal to 1. Then to get the x-intercept, we need to plug in 0 to y. So if y is 0, we solve for x, then therefore x is equal to negative 1/3. Okay. Now, we know that we need to get the intersection of the modulus with the line y is equal to 4. So therefore, to get that intersection, we plug in 4 to y, then solve for x. But we know that if y is equal to 4, then that would be 4 is equal to 3x plus 1. And there's another possibility that is 4 is equal to negative of 3x plus 1. So let's solve for x. So here we have 4 minus 1 is equal to 3x, or 3 is equal to 3x, or x is equal to 1. So this is our first point, 4, 1. Okay. For the other one, we have negative 3x minus 1. So we solve for x. We have 3x is negative 1 minus 4. Okay. Or 3x is equal to negative 5. Or that is x is equal to negative 5 by 3. So that is our another point. That's negative 5 by 3, 4. So now, we can now graph. Okay, so we have the y-intercept 0, 1. Then we have the x-intercept negative 1/3, 0. So that's probably over here. Then we have 1, 4. Then we have negative 5/3 is negative 1 and 2/3, right? So that's probably around here. Then 4. Okay. So this would be our graph of the modulus y is equal to the modulus of 3x plus 1. Okay. So to find for the solution set, we are looking for all the values of x that is less than or equal to 4. So meaning if it is less than, it should be under this line. So looking at our graph, we are interested with those below this line, below the line y is equal to 4. So we are talking about this part. Okay. So we know here the value of x is negative 5 by 3. And here the value of x is 1. So therefore, our solution set would be all the values of x between, so that is greater than or equal to negative 5 by 3 or less than or equal to 1. Okay, so again, if you were able to graph it this way, give yourself 1 check. And if you're able to identify the solution, give yourself 1 check. Okay. So let's go to the next number. We have 1D. So again, oh no, that's 1E, I'm sorry. So again, we need to solve this graphically. So that is the modulus of 3x plus 2, 3x plus 2 over 2 is less than 4. So again, we need to isolate the modulus. So we multiply both sides by 2. So that will give us the modulus of 3x plus 2 is less than 8. Okay, so now that we have isolated the modulus, so let us now graph. So the first one that we need to graph is y is equal to 8. So this is our x-axis. Okay, and this is our y-axis. Okay, so where is y is equal to 8? So let's graph that. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is our line. Y is equal to 8. Then we also need to graph the modulus of 3x plus 2. Again, to graph this, we need our table of values. So first, we need to look for the y-intercept. So to get that, we need to plug in 0 to x. So if x is 0, then y is equal to 2. Then we need to get the x-intercept. So to do that, we need to plug in 0 to y. So if y is 0, then x is negative 2 by 3. Okay. Then, again, we know that we need to know the intersection of the modulus of the graph of the modulus and y is equal to 8. So, to do that, let us plug in 8 to y. So again, if y is equal to 8, then that would be 8 is equal to 3x plus 2. But there is another possibility. So that is 8 is equal to the negative of 3x plus 2. So we have, so for x, we have 8 minus 2 is equal to 3x. 8 minus 2 is 6 is equal to 3x. Or x is equal to 2. So this will be our first point, 2, 8. For our second point, we have 8 is equal to negative 3x minus 2. Or that is 3x is equal to negative 2 minus 8. Or that is 3x is equal to negative 10. Or x is equal to negative 10 by 3. So this is our next point, negative 10 by 3. Okay, so let us graph. So we have 0, 2. So this is that point. Then we have negative 2/3, 0. So this is point. And we have 2, 8. So we have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we have negative 10 over 3 is negative 3 and 1/3. So we have negative 1, negative 2, negative 3, and 1/3, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that will be approximately here. Okay. So let us now graph. Oops. Be a straight line. V shape. So this is y is equal to the modulus of 3x plus 2. So again, the values that we are interested in is the values that are less than 8. So that would be below the line y is equal to 8. So we are interested with this part of the graph. Okay. So that is the x value here is negative 10 by 3, and the x value here is, what's that, 2, right? So therefore, our solution set would be in between these two x's. So that would be x is greater than negative 10 by 3, but less than 2. Okay. So again, if you're able to graph it this way, give yourself 1 check. And if you were able to identify the solution set, give yourself another 1 check. Okay. Let's go to the next number. So we have 2b. So we have the modulus of 2x minus 7 less than 4 for x greater than 0 but less than 6. Okay. So again, to solve this, we need to graph y is equal to 4. Okay. So if this is our x-axis, and this is our y-axis. Okay, so y equals 4 would be 1, 2, 3, 4. Would be this now. So this is y is equal to 4. Okay, then the next thing we need to do is graph the modulus. So that is the modulus of 2x minus 7. So again, to graph this, we need the table of values. Yes. So to start with, we will start with the y-intercept. And to get the y-intercept, x must be 0. So if x is 0, y is equal to what? If x is 0, then y is equal to negative 7, right? Then if, oh, it's not negative, it should be positive because it's always the absolute value, right? You are getting the modulus. Yes, it should be positive 7. All right. We have, if y is 0, okay, then we'll solve for x. So that would be 7 by 2. Okay, so again, we know that we are looking for the intersection of the modulus and the y, right? So in order to get the intersection, we plug in 4 to y. But we know that if y is equal to 4, then we have 4 is equal to 2x minus 7. And we also have 4 is equal to the negative of 2x minus 7. Okay, so we have, so for x, we have 4 plus 7 is equal to 2x, or that is 11 is equal to 2x, or that would be x is equal to 11 over 2. So that would be our first point, 11 over 2, 4. At the other side, we have 4 is equal to negative 2x plus 7, or that would be 2x is equal to 7 minus 4, or 2x is equal to 3, or x is equal to 3 by 2. Okay, so that would be 3 by 2, 4. Okay. But we are looking for the graph from 0 to 6. So let us look at the behavior of the graph if x is 6. So if x is 6, then we have 12 minus 7. So that would be 5, right? Okay. So let us graph. So we have 0. We have 7. 1, 2, 3, 4, 5, 6, 7. Okay. Then we have 0, 7 over 2. 7 over 2 is somewhere 3 and 1/2, right? We have 1, 2, 3, and 1/2. So that is this point. Okay. Then we have 11 over 2, 4. 11 over 2 is 5 and 1/2, right? So we have 1, 2, 3, 4, 5 and 1/2, 4 here. Okay. Then we have 3 over 2, 4. 3 over 2 is 1 and 1/2. 1 and 1/2. So that will be here, 4. Then we have 6, 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 5. Okay, so we graph. Oh, sorry. There you go. So, just to find the solution, we need to look for the all values of x that are less than 4. So we are interested with the part of the graph that is less than 4 or below the line y is equal to 4. So we are interested with this part. Right. Okay, and we know that the x here is negative 3 halves, 3 by 2, and the x here is 11 by 2. So, oops, sorry. So therefore, our solution set would be the in between the x values. So we have x is greater than 3 halves, but less than 11 by 2. So again, if you're able to graph it this way, give yourself one check. And if you were able to find the solution correctly, give yourself one check. Okay, then let's have 2C. So for 2C, we are again asked to solve graphically 0.25 times the modulus of x minus 3 less than or equal to 0.5. So again, to do this, we need to isolate x minus 3. So we divide both sides by 0.25. So that would be the modulus of x minus 3 less than or equal to 2, right? Oh, by the way, we need to graph this for x greater than 0 but less than 6. Okay. So first thing we need to do is we need to graph y is equal to 2. Okay. So we have this. For example, this is our x-axis. And this is our y-axis. Okay. So y is equal to 2 is here, 1, 2. Okay. So this is y equals 2. Then we also need to graph y is equal to the modulus of x minus 3. So, no. To do this, we need the absolute, the table of values, right? So again, let's plug in for 0 to x to get the y-intercept. So that would be, this is equals, okay? So that would be y is going to be 3. Now, if y is 0, then we have what would be the value of 3 of x, then that would be 3. Okay. And we know that we need to look into the intersection of the modulus and the graph, right? So we have, so we need to plug into to y. So if y is 2, then we have 2 is equal to x minus 3, or we have 2 is equal to the negative of x minus 3. So we have x is equal to 2 plus 3, or x is equal to 5. So this is our first point, 5, 2. Then we have 2 is equal to negative x plus 3, or that is x is equal to 3 minus 2, or x is equal to 1. So this is our another point, 1, 2. Okay, but okay, so let's try to substitute 6. So if x is 6, then y is 3. So we can now graph. So we have 0, 3. Then we have 3, 0, 1, 2, 3. Then we have 5, 2. This is 3, 4, 5, 2. Then we have 1, 2. Then we have 6, 3. 1, 2, 3, 4, 5, 6, 3. So this will be our graph. Okay. So again, we are interested with the values of y that are less than or equal to 2. So that should be below the line y is equal to 2. So we are interested with this part. Okay, wherein the x value here is 1 and the x value here is, what's that, 5. Yes. So therefore, our solution set would be the values of x that are in between these two. So we have x is greater than or equal to 1, but less than or equal to 5. So if you were able to graph it this way, give yourself 1 point. And if you were able to identify the solution set, then give yourself another point. Okay, so I guess that would be all for our assignment. I hope you got the perfect score. So what's the total score for 2C? We have 2 points. 2B, we have 2 points. So 1E is 2 points also. 1C is 2 points also. And 1B is 2 points also. So therefore, the total points for this assignment would be 10. Okay, so please count the number of your checks. Okay, then I'll ask about your score next meeting. Okay, so we know that we can also solve this algebraically, right? And let us review how are we going to solve this algebraically. Okay, let me use a different color pen. So to solve algebraically, okay, so we have here x minus 3 less than or equal to 2. But we know that to solve this algebraically, we can write this. We will write this as, remember, I will write it here. We have x. If we have this one, x plus a less than b, then to solve algebraically, we will write it as negative b less than x plus a less than b. Then we solve for x. Okay, so let's do that here. So we have from here, okay, so we can write it as x minus 3 is greater than negative 2, but less than 2. So we solve for x. So that would be negative 2. We have here x minus 3. Okay, we need to add 3 here. So if we add 3 here, we'll also add 3 here. And we will also add 3 here. Okay. Don't forget to write the inequalities. So this is now going to be 1x 5. Right? Oh, this should be less than or equal. Okay. So that's how we do it algebraically. So you see, the answer are the same. Okay. Now, Let's have another case. Okay. Remember, in our assignment, the cases are of the form AX. So in our assignment, the cases are the modulus of AX plus B less than C. Now, we will talk about what we're going to do if the inequality is greater than. Okay. So, for example, we have the modulus of x greater than 3. So, how are we going to solve this graphically? So, the modulus is already isolated at one side. So, we graph y is equal to 3, right? So, if this is our x-axis, okay, and this is our y-axis. So y is equal to 3 is 1, 2, 3. Okay. So this is our y is equal to 3. So after graphing that, we now graph y is equal to the modulus of x. Okay. So we know that the graph of this is a v, right? But anyway, let us write the table of values. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, y is still 1 because that is the absolute value. So we are looking for the intersection of 3. So if x is 3, y is 3. If x is negative 3, y is 3. So let us graph that. So we have 0, 0. Then we have 1, 1. We have negative 1, 1. We have 1, 2, 3, 3. Then we have 1, negative 2, 3, negative 3, 3. So this will be our graph. Okay. Now, examine now the graph. What are the values that we are interested with? The values that we are interested with are those values that are greater than 3. So meaning all the values that are more than this line or above this line. This is 3, right? So more than would be above this line. And what part of the graph that is? So this is that part of the graph. And this part. Okay. And we know that the x value here is negative 3. And the x value here is positive 3. So therefore, what is our solution set? So therefore, our solution set, how are we going to represent this part if we know that this is negative 3? So this part are all the values of x that are less than negative 3. And how are we going to represent this part of the graph when we know that this point is 3? So all the x's here, right, that is 4, 5, and 6 are greater than 3. So that is x is greater than 3. Okay, so note that this is our theorem. Given the inequality, the absolute value of x or the modulus of x greater than a, the solution always starts by splitting the inequality into 2 pieces. So that is x is less than negative a or x is greater than a. So you see, it satisfies the theorem. Okay? Let's have another example. So for example, we have this one. We are going to solve the modulus of x plus 2 greater than 3. So again, to solve this, we are going graphically, take note, we are solving graphically. So we need to graph y is equal to 3. So if this is our x-axis, and this is our y-axis, okay, so y is equal to 3 would be 1, 2, 3, right? So this is y is equal to 3. Okay, then let us also graph the modulus of y is equal to the modulus of x plus 2. So again, to graph this, we need the table of values. If x is 0, y is 2. If y is 0, then x is negative 2, right? And we know that we need to get the intersection. So we plug in 3 to y and solve for x. But we know that if y is equal to 3, then we have 3 is equal to x plus 2. And we also have another case wherein 3 is equal to negative of x plus 2. So we have x is equal to 3 minus 2, or x is equal to 1. Or this is 3 is equal to negative x minus 2, or x is equal to negative 2 plus 3, or that would be x is equal to 1. So you see they are the same, so we'll just have 1 point for that. So that is 1, 3. Okay. So let's find another possibilities. Okay. So we have, I'm sorry. No, I'm sorry. I got it wrong. It should be negative 2 minus 3. Yes. Should be negative 2 minus 3, or x is equal to negative 5. So we have negative 5, 3. So there you go. Okay, I'm sorry for that. So we have 0, 2. So that would be, so let's graph. So we have 0, 2. Then we have negative 2, 0. Then we have 1, 3. Then we have negative 5. 1, 2, 3, 4, 5, 3. Okay. So this is our graph. Okay. Now let us examine our graph. We are looking for the values of x that are greater than 3. So meaning the above of this line. So we are interested with the part of the graph of the modulus that is above the y is equal to 3 line. So we are interested with this part. So the solution set lies on this part of the graph. Okay, and we know that the value of x here is negative 5. And the value of x here is 1. So therefore, our solution set would be the values of x at this part of the line would be, take note, this is negative 6, negative 7, so that is x is less than negative 5, or the values of x here at this part would be, these are 2, 3, 4, so that would be x is greater than 1. So this is our solution set. Okay, so I hope you got that. Now, let us now solve graphically. Okay? So, for example, let us do the previous example. So that is the modulus of x plus 2 is greater than 3. Okay? So by definition, okay, this is our definition, right? But we can extend this. Oh, I'm sorry. So we can extend this to given the inequality, the modulus of x plus ax plus b. Okay, let's do that. Ax plus b. Greater than c, then the solution okay, always starts by splitting the inequality into two pieces. So that is, first one is we have ax plus b is less than negative c, or the other one is the modulus of ax plus b is greater than c. So following this, we have to solve this. So we apply the theorem. So we apply the theorem. Okay, let me just enclose this. Okay. So we apply the theorem and rewrite the inequality, the absolute, okay, inequality. Oh, by the way, I'm sorry. There should be no more absolute value here. Okay. And rewrite the absolute inequality as a compound inequality. So again, by definition, we can write this as x plus 2 is less than negative 3, or we have x plus 2 is greater than 3. Then we solve for x. So we have x is less than negative 3 minus 2, or x is greater than 3 minus 2. So we have x is less than negative 5, or we have x is greater than y. So this is now our solution set. Going back, do we have the same? Yes, so we have the same solution set. Okay. So let us have another example. So this time we'll solve this algebraically. So again, the first step would be to, so first, let us isolate the modulus at one side of the equation, of the inequality, sorry, of the inequality. Okay, so that is we have 3 plus 2 times the modulus of 4x minus 7 greater than or equal to 13. So we transfer 3. So we have greater than or equal to 13 minus 3. So we have 2 times the modulus of 4x minus 7. So that is 10. And then we have divide both sides by 2. So we have the modulus of 4x minus 7 greater than or equal to 5. Okay, now that we have isolated the inequality at the modulus at the one side of the inequality, we now split. Okay, so we rewrite the absolute inequality, the absolute value. I'm sorry, that should be absolute value. The absolute value inequality as a compound inequality. Okay, so you're going to write it as 4x minus 7 is less than or equal to negative 5, or we have 4x minus 7 is greater than 5. Then we solve for x, so we have 4x is less than or equal to negative 5 plus 7, or 4x is less than or equal to 2, or x is equal to 1/2. And here we have 4x is greater than 12, and then we have divide both sides by 4. So we have x is greater than 3. Okay? So this is our solution set, these two. Okay? Let's have another one. Okay? So we have this one. So again, we isolate the modulus at one side. So we have the modulus of 2x minus 1 is greater than 2 minus 5. So this is the modulus of 2x minus 1 greater than negative 3. Now, is this possible? Is this possible? Okay. Notice that we know that the absolute value of anything is positive, right? Now, is it possible to have a positive number that is greater than negative 3? Okay. So notice that we have an absolute value greater than a negative number. Okay. And we know that for any real number x, okay, the absolute value will always be positive. Hence, any real number, whatever we plug into x, that will always be greater than negative 3, right? So, therefore, okay, the solution set is all real numbers. Okay, so take note of cases like this. Okay, so you always check, okay, what you are solving. Okay. Now, we are done with the form ax plus b less than c and ax plus b greater than c. Now, this time, we are solving absolute values on the both sides of the inequality. Okay? Previously, we are just having absolute values on one side. So this time, we are solving absolute values on both sides of the inequality. Okay? So, how are we going to do this? Okay? So, first case is to take each side as being positive values, then solve for x. So that is, we equate ax plus b to cx plus d. The second case would be, we multiply the right-hand side by -1, then solve for x. Okay? So that is, ax plus b is equal to the negative of cx plus d. Okay? Then after finding the critical values, we test the points between the values. Okay? So for example, we have this one, 2x plus 1 is greater than 3x minus 2. So let us have the first case. So the first case is we equate them, right? So we have 2x plus 1 is equal to 3x minus 2. Then we solve for x, so we have 3x minus 2x is equal to 1 plus 2. So 3x minus 2x is x, and 1 plus 2 is equal to 3. Okay, then case 2. For our case 2, we have 2x plus 1 is equal to the negative of 3x minus 2. So that would be 2x plus 1 is equal to the negative of 3x plus 2. Or that would be 2x plus 3x is equal to 2 minus 1. Or that is 5x is equal to 1. Or x is equal to 1 by 5. Okay, so we have here two critical points. So the two critical points are, we have x is equal to 3, or we'll start with the lower one. So we have x is equal to 1 by 5 and x is equal to 3. Okay, so we use a value of x between these critical points. Okay, as a test. So for example, what is the value of x that is between 1 over 5 and 3? Okay, let us look at the number line. So if this is 0, if this is 1, if this is 2, this is 3, and this is probably 1 over 5 is going to be here. So what are the possible values of x between 1 over 5 and 3? Okay. So meaning we can choose 1 or 2, right? So let's choose 1 so that it will be way more easier. So if x is equal to 1, then let us test x here. So we have 2x plus 1 greater than 3x minus 2. So we plug in x, so we have 2. times 1 plus 1, is it greater than 3 times 1 minus 2? So we have 2 times 1 plus 1 is 3, and 3 minus 2 is 1. Is this true? Yes, so this is true. This is true. So the solution set is between the critical values or the critical points. So therefore, the solution set is x is greater than 1 by 5, but less than 3. Okay, so that's how we do it if we have two absolute values. Okay, let's have another one. So let's solve the modulus of 3x minus 2 greater than or equal to 2x plus 5. So again, we have case 1. Case 1 is we equate them. So we have 3x minus 2 is equal to 2x plus 5. So we solve for x. So we have 3x minus 2x is equal to 5 plus 2, or that is x is equal to 7. Then case 2, we have 3x minus 2. We equate this to the negative of 2x plus 5. So we have 3x minus 2 is negative 2x minus 5, or that would be 3x plus 2x, or that's negative 5 is equal to negative 5 plus 2, or that would be equal to x is equal to 5x is equal to negative 3, or that would be, I'll write it here, okay, x is equal to negative 3 over 5. So therefore, the critical points are x is equal to negative 3 by 5 and x is equal to 7. Okay, so let us graph that on a number line. So if this is 0 and this is negative 1, then negative 3 over 5 would fall under somewhere here, right? So that's negative 3 by 5. So we have 1, 2, 3, 4, 5, 6, 7. And this is our 7. So let us choose any value of x in between the two critical points. So any value in between them. So we can choose 0, 1, 2, 3, 4, 5, or 6. Okay. Suppose if we choose 0, if x is 0, then let's use this. So we have, okay. Oh, let's use this. So we have 3x minus 2 greater than or equal to 2x plus 5. We plug in x. So that's 3 times 0 minus 2 is greater than or equal to 2 times 0 plus 5. So we have negative 2 is it greater than or equal to 5? Is this true or false? Okay, so we know that this is false, right? So this is false. Okay, so the solution set is outside the critical values. So therefore, the solution set would be this part and that part, okay? So therefore, the solution set would be this part and that part, not in between, okay? So are we going to write that? Then therefore, that would be x is greater, less than, okay, oops, sorry, is less than or equal to -3/5 and x is greater than or equal to 7. Okay, so okay, I will be discussing this next meeting. So for today, that would be all. Now, I hope you were able to understand our topic. Okay, so now for me to know if you were able to understand our topic, please do these exercises, okay? And upload it in our Google Classroom under classwork, okay? Again, this is for me to know if you were able to understand our topic, okay? Let me share my screen, okay? So please answer. So please answer. Oops, I'm sorry. Okay. So this is a sit work. So answer, then upload your work in our Google Classroom under classwork. So answer exercise 3.2, page 63, numbers 1A, 2A, and 3 letters A to D. Okay? So please do this and upload this in our Google Classroom. And I will see you tomorrow. Okay? Have a nice day, guys.